start with our first introduction to an Arduino microcontroller. So today we're going to look a little bit at the Arduino microprocessor. We're going to look a little bit at light emitting diodes. We're going to talk about some circuits. We're just going to build a really easy circuit. And we're going to learn a little bit about breadboards. And we're going to use a breadboard. Protoboard, sometimes it's called a prototyping board. So first of all, let's talk about an LED. So here, let me draw a picture of an LED. You probably have seen LEDs, of course. They come in all shapes and sizes, but this time I'm going to draw an LED, and it's going to look something like this. It's got two wires on it. Light shines out of it. We're good to go. So electrically, if we're electrical engineers and we want to draw an LED, what we do is we draw an LED that looks like this. So this is a diode. So that's a normal diode. A diode is, it allows current. It's a one-way valve for current, for electricity. So it allows current to flow this way and not the other way. So we're going to look at that a little bit. One of the things about a diode is it has a fixed voltage drop. A good rule of thumb is it's 0.7 volts. That's not always the case, but in this case we can assume that. And so what happens is if I put 5 volts across this diode, it's going to get, so 0.7 of those volts goes across here, and so you can imagine if you put just a bare wire across 4 volts, it's going to get hot. The LED is going to get hot too, but electrically it's going to get really bright and then burn itself out. So what we're going to try to do, we're going to talk about putting a current limiting resistor in here. So we'll draw a picture of a resistor here. We'll put that down to ground. And then we'll call this our current limiting resistor. Oh, in order to make this an LED, so this is a diode. If we wanted a light emitting diode, we just have to put some arrows coming out of it. And the arrows indicate that there's light coming out of it. That way the electrical engineers will know well, that this is an LED. So I'm going to use the only equation that I know from electrical engineering. It's V equals IR. And so V equals IR is my equation, and I know some things about it. So this voltage is, it's not really 5 volts, it's 5 minus 0.7 is the voltage. The current, again, this is based on specifications, you have to look, but I'm gonna put 20 milliamps is a good rule of thumb. It's a good rule of thumb to use, and then we don't know how big is our current limiting resistor, and so now we have to go and find out what our current limiting resistor is, and I'm just going to approximate this voltage drop as 5 over 20 E minus 3. That's going to be 1/4 E3, or about 0.25 E3, or about 250 ohms. Okay, so nobody cares. So the current limiting resistor, this is kind of an estimate. If you're really trying to get as much current as you can through there, you might go ahead and do an exact number here. But also nobody really cares if you have a current limiting resistor on the order of 300 or 400 ohms. That's gonna be okay. All of those will work just fine. So let's talk a little bit about our Arduino microcontroller. So I'm going to draw a little picture of what kind of a rough diagram. So you have an Arduino board. On the Arduino board, there's like a USB connector you can plug in up at the top there. And you'll notice on the side there's a couple of banks of little sockets that you can plug things into. They're square, so I'm kind of going to show them as a square. I'm not making as many as there are. What you want to go look at is the 5-volt one, and right under it you'll see one that says ground. And so now what we're going to do is we're also going to, we want to be able to, so we're just going to start by using our Arduino microcontroller just as a voltage supply. So you can plug that into your computer. That will give you 5 volts here and ground here. And if we're trying to do our circuit, what we're going to do is we're going to look at our proto board. Now, if you haven't used a proto board before, you'll see it's got little it's got little holes in it, and you can see I'll draw some little holes, and it's got 2 sides of little holes. And so what happens is on a proto board is that the little holes in one row are all electrically connected to each other. So if you plug something into one of the little holes in this row, and then plug something else. If you put a wire into the other one, it's as though you've soldered that wire together. So each one of these, this is one set of electrical connections, and then this is a second set of electrical connections. So those are two different ones that you might have. Oops, dropped my pen here. All right, so what we're going to do is we're going to start with our very first circuit now. So here's our very first circuit. So what we're going to do with our very first circuit is we're going to look at our electrical schematic, and we see we need to have 5 volts, and 5 volts needs to go through our LED, and then the LED, and then we need to have that go through, that same current has to go through our resistor and then to ground. And so what I'm going to do is, so let's see, so here's 5 volts. So I'm going to put a wire here. That's this part. It's to the top of my LED, light emitting diode. So now I'm going to put my LED in here. So here's my LED. I'm going to put it this way. I'm going to draw my schematic diagram of it. You would have a real LED, and we'll put it from this one to that one. So they're not electrically connected, but you see these two are electrically connected. So I have 5 volts going through my LED, and if I look at my circuit diagram, now what I need is I need my LED to go through my current limiting resistor, R sub L, and it needs to go to ground. And so what I have to do is I'm going to go find another wire, and I'm going to put that into ground. Boom. If I do that, I should see that as soon as I plug in my ground, that my LED lights up, and if I unplug it, it should unlight. Okay, so let's try that circuit. That's the easiest first thing to do. Good. We've got our lights hooked up. You'll see that I've taken out the 5-volt power supply to our LED, because right now what we're going to do a little bit about programming. So we're going to go to the Arduino programming graphical user interface. No, that's called a programmer development environment. Programming. So we're going to program something. So what we'll have to do, what we want to do is we want to open the Arduino integrated development environment. Those are IDEs, so that way if you want to impress your friends and acquaintances, you say, oh, I use the Arduino IDE. So we're going to open the integrated development environment first of all, and the next thing that we're going to do, we're going to now we're going to start writing our very first program. And so in programming is written in C code, written in C. So you can say, oh, I program in C too. And so the very first thing that we have to do is we always have to declare our variables. And what we're going to do is we're going to declare our first variable. Let me declare that variable int. So that means that it's an integer. In this case, integer's whole number, right? So so now we need to make up our own number. So I'm going to call this LED pin. That's perfectly good. Int LED pin. So that says what it is. And I'm going to define this integer, so the word LED pin is the number 11. And the reason I'm going to put it in is number 11. So what I'm telling you is that the pin that I want to be the LED control pin is pin 11. And if I go back and look at my Arduino microcontroller, on this side I can see 13, 12, and 11. You'll see there's like a little squiggly line next to these. I think that means so that means that those are input-output pins. And in the Arduino microcontroller, all right, so now we've declared our pin as an integer, and there's another piece of it, it's a void. So now we got another piece of our code, it's void setup, and there's a parentheses, and then there's begin. And so what I want to do is I want to declare the pin mode, and I want to tell what the pin number is. So in this case, I could put an 11 in here, but since I already have something, this is LED pin, comma, output. So I'm declaring this as an output pin. And then I want to make sure that it just in all cases with C, the way I end a line is I close I put a semicolon on the end of the line. That tells the C code that it's the end of the line. Then I'm going to close my bracket. So now I have void set up. And now I'm ready to do my loop. There's another piece of the loop, void. You'll see these are built in. When you open up your very first program, these blocks will already be in there. These are just things that you have to put into your blocks. Oh, I'm just seeing here that this one is supposed to be a capital letter, pin mode. And so now I'm going to say void loop, and the loop looks like this. And now I'm gonna do what I have to do in the loop, and all I have to do in the loop is I'm going to do a digital write, D-I-G-I-T-A-L, digital, W-R-I-T-E, digital write, and I want to, this is a built-in function. I want to have the digital write command. I want it to go to a specific pin. I want it to go to the LED pin. Again, I could put the number 11 in here, but I'm using variables so that we get a little bit of experience using the variable. And I would like that to be high. H-I-G-H. Okay, and then I'm gonna write. There's another command that we can use is delay. The delay, and so this is delay is in milliseconds, delay 1000. You'll notice I put a semicolon here. I'm going to put a comment line. This is one way that you can comment in C, and that I'm going to write down here milliseconds, so we know what the delay is. So now I've turned on my LED pin. That's pin 11. I'm going to wait 1000 milliseconds, which is 1 second, and now I'm going to also say digital write, that's a lowercase, and I'm still going to go to that LED pin, and I'm going to make it go low, semicolon. Again, it would go low, and then it's going to circle around and go back to its loop. So what I want to do, I want to also put a delay right after that. Delay 1000. I've got my semicolon. And now I'm done with my loop, so I can put my closed bracket here. And this is my loop. So if I do this, the only thing I have to do now is I have to take pin 11. I'm going to take a wire from pin 11, and I'm going to put it into my high of my circuit. So now I'm ready to go. So I'm going to let you guys do this, and once you're finished doing it, what I'd like to have you do, I'd like you to mess around with these numbers a little bit so that you can maybe it turns on for a long time, turns off for a short time. Maybe you do a little work with that. And so we're going to test that out and see how it goes. Okay, good. Okay, so now we've learned a little bit about potentiometers, and we're ready to install the potentiometer onto our Arduino system. We don't have to do anything with our current LED. We've got that working fine. We can turn on pin 11 and turn off pin 11, and we can make our light go on and off. So I'm going to maybe add another row or two of these little guys right here so that we have some things to do. So let's see, what I'd like to do, I guess I'm just going to go ahead and do it more directly. What we have a little potentiometer. If you go look at whatever the little potentiometer that we have, it's got like a little slot in it. It's got like a little, so our potentiometer looks something like this. And how many wires come out of a potentiometer? There's 3 wires that come out of a potentiometer. We have to have a plus wire, minus wire, and a measure wire. So we'll have 3 wires that are going to come out of our potentiometer. And what I'm going to do is I'm going to show us how. So let's make sure that we have our schematic hooked up. Let's see, we already have a ground wire, so why don't we do this? We have to hook this wire. We maybe need to hook this. This is just one way of doing it. I'm just doing it on my schematic. So there, I've got my ground hooked up. Right? I've got my ground hooked up just fine. And so now, maybe what I'll do is put my potentiometer this way. Now I'm going to have it upside down, but that's okay. You'll be able to figure out what I'm doing with it. So here's my potentiometer, here's my measurement, and this is my wiper. So I'll put an arrow on the wiper that shows that it can move up and down. And then I'm going to go ahead and put this to the positive, and I'll go ahead and put this one to the center one. So now we have to just hook this up to our Arduino, and we'll hook it up to our Arduino. So we already have that one hooked to ground. That's good. We probably need to hook this one to 5 volts. There's a couple of different ways to do that, but why don't we do that 5 volt this way? Let's do the 5 volt this way. There, that's a 5 volt, right? We put a 5 volt in here. And this one now needs to hook to the A0. Oops, I forgot to look and make sure I know which one A0 is. So I believe this is the A0. So that's the analog input. That's pin number 0. And so we want this one. Then, let me get a good color here. Let's see if I've got orange. There we go. So that's our entire schematic that we need. So what we have to do now is we have to talk a little bit about, programming. So let's do, so one of the things that we have to do, we're going to use a variable that we're going to read off the digital to analog converter. And so let's call that, this is going to be int. Let's call this pot value. So we're going to, in our variable declaration section, we've got to add an integer that is the name of whatever it is we're going to read out of that A0. And then what we'll do is, I just got to look and make sure that I know exactly what these things look like. So we also, in our setup section, what we're going to do is we want to do serial dot begin 9600. So this enables our serial communications. And then we also want to use a function called pin mode. The pin mode is, so we're going to use our LED pin. Remember, we've already declared that on our last one. Okay. Up here in our integers, we also have to declare a new kind of integer. So we've declared our pot value, and I'm going to call this one sensor pin equals A0. So sensor pin is A0, so this is our A0. I should make sure that we know that that's an A0. So that's our void setup. So what this does, this serial.begin allows us to start sending serial messages out from the Arduino to our computer. You know, we still have our computer hooked up here to our computer monitor, so we can get serial that way. And so now what we're going to do is we're going to assign a value. So in our void loop, begin paren, so in our void loop, what we would like to do is we would like to assign our pot value equals analog.read A0. Oh, you know, I called it A0, but I could have also called it, because A0 are the same thing, I could have also called it sensor pin, right? So I could have called it that way. We want to make sure that we put a semicolon after that. And then let's print that out. So we're going to do serial dot print line. We're going to do serial print line pot value. It's hard to believe I can't remember to do these things. Serial print line value. And then let's set up the delay time. So we're going to do delay time. So let's figure out how much time we'd like to have it delay. And what we'll do is we'll just make the delay time, let's just make it pot value. Let's just make it pot value. So it turns out that when we read this analog input, this number right here is a 2 to the 10th. It's a 10-bit number, which means it goes from 0 to 1023. So that's how that works. And so now we could just put the delay time in the pot value. There's a little bit of a question mark I have to write here. It's like, so we know, oh no, I guess this is okay. This is in milliseconds, so it's possible that we could have 1023 of those milliseconds. I think that's okay to do that. And then we'll just go ahead and say delay. We'll delay our program. delay time. Now, be careful because you're going to get an error out of this, because up here we have to say int delay time. Right? We have to know what our delay time is. And so I won't finish up the rest of this stuff, but so now we've got our hardware, we've got the pieces of our code that we need to modify, and we should be able to just go ahead. Let's just go ahead and get in there and plug in our potentiometer and do some testing with it. Oh, one thing that we should do this. Sorry, one last thing. We should make sure that we double check that we look at the voltage, volts, V-O-L-T-S, volts coming in, and we should match those to the value of the sensor reading. And so that means that we should double check, with a voltmeter, we should double check that when we have 0 volts, our sensor reading should give us 0. And when we have 5 volts, our sensor reading should give us 1023. And you know, you just don't have to do any more than that if you don't want to, but I'm going to ask you to do 2 or 3 other places in here so that we know that we have reasonably straight line on this thing. So now what we have is we know what the relationship is between our readings, which this is what we can read, and our voltage, and that's our voltage. Okay? All right, go to it.